All right. So hello, everyone, and welcome. I want to thank all of you for taking time out of your very busy schedules to hear our presentation today. We are Centralized Network Automation here on behalf of the University of Wisconsin-Stout CNIT program. This is our UW-Stout CNIT 2020 Spring Capstone presentation. We are sponsored by Menards Incorporated. They tasked us with implementing a configuration management solution, and we want to give a huge thank you for Menards for sponsoring our Capstone group this semester. So I want to start off this presentation by introducing our group to you. I am Corbin Knipfer, the team lead and network manager for the group, and just finishing an over 2-year internship with Menards.
Hi, I'm Carl Carey. I'm the systems engineer.
Hi, I'm Dakota Herda. I'm just finishing up my 1-year internship with Menards, and I am also a system engineer on this team.
We also want to thank our sponsors for giving us this project to implement and for all of their hard work behind the scenes that they put in to help us be successful. First off, we have Justin Arrington, who's the manager of infrastructure networking. Kevin Wagner is the team lead, networking team lead, and Jason Wers is a senior network administrator. So today's agenda is going to begin with an introduction to configuration management, and we'll kind of discuss what it is. Then we'll lead into some of the solutions Menards wanted us to use and implement. After that, we'll dive into each part of the statement of work and show you kind of like a high-level overview of how we accomplished each section. That will lead right into our live demonstration of our configuration management solution working. And finally, we'll wrap up with a conclusion detailing some of the challenges and some of the lessons we learned from those challenges, as well as giving our recommendation on the project. So now I want to get a little more specific on what was required of our group and the problem that Menards wants our capstone specifically to address. So pay attention to the underlined words as they're key to this project. In order to control infrastructure costs and become more agile, Menards Incorporated is looking to deploy a configuration management system that can improve the efficiency and flexibility by using open source technologies and multi-vendor environments. So now I'm going to hand it off to Dakota. He's going to talk about that first phrase, configuration management, and why it's so important.
So here we can talk about configuration management. You can see we have the quote up there. You can pay me now or you can pay me later. Honestly, what that comes down to is you can spend the time maintaining the status quo of having your administrators and engineers pushing out the same configuration changes to hundreds, possibly thousands of devices, and honestly doing a lot of menial tasks that are very time consuming. Configuration management, the whole idea of it is to have this sort of DevOps mindset where we're constantly improving, constantly building on our previous code and how we can automate these things to free up that time. The tools we use to do this in particular were Ansible and Git, and you see those be shown in our later live demonstrations. So kind of the 4 big things about configuration management and planning are, as you can see here, identification. We want to figure out what those problems exactly are. We want to be able to control how they're impacting our team. And we also want to be able to monitor the status of our actual network devices in this scenario. Finally, we're also going to verify and audit those devices to make sure they're up to specific compliances, make sure they're configured exactly how we want them to be, and following that, be able to make the changes as necessary.
So I'll start off with the business goals and objectives for this project. They all kind of relate to each other. Cost savings, like Dakota said before, you can either pay your employees to maintain the status quo, or you can save costs with a little bit of upfront time to implement these configuration management solutions. So with that, after you have finished the upfront cost, your employees have more free time. And with that free time, they have the ability to start more complex projects. The technical goals and objectives for this project, we needed to create a multi-vendor environment using Juniper switches and Cisco routers and switches. We need to use Ansible and Git to complete the configuration management section. And we need to create playbooks for some major redundant tasks that network administrators usually have to face.
So here I'd like to kind of talk about what exactly Ansible is. To start with, it is an open source tool so what that comes with is, it's free. There's no kind of licensing you have to pay for. You could just download it off the website and start configuring it to, your own needs. Another big aspect is that it is agentless, and what this means is that you don't have to install any kind of special software on your end devices in order to manage them. Now, this is big for a network, especially the size of Menards, where we have hundreds, potentially thousands of routers, switches, etc. A lot of those devices can't support installing third-party software by default. So having Ansible be able to be a centralized node that doesn't have any kind of special software required is a big bonus. And finally, Ansible uses what's called playbooks. And what this is it's their method of kind of simplifying the that low down, that ugly kind of scripting that you're used to seeing. So Ansible under the hood is actually written with Python. However, their playbooks allow you to use their built-in modules in the simplified YAML format, which is human readable and easy to troubleshoot if things go wrong.
Thank you, Dakota. So the next solution I want to discuss in Git is Git and how it traditionally is used and also how it kind of fits our environment. So first off, it's also an open source solution that is an industry standard for developing and deploying code. The reason developers use Git in a coding environment is because it's very good at version control. And our group is using Git in much the same way by putting our playbooks on Git to keep a revision history of them. So this way, changes can be tracked and reverted back if necessary. So this graph on the right kind of shows how Git operates. You start at the bottom with a working directory where you can make files, edit them, and then add them to be staged. Once they're staged, you can commit those files and suddenly a history of that file is made. From there, we can check out that file again and work on it, or we can just reset them. This operates in a loop where multiple people can be working on files and tracking changes made by each of those individual people. So next, Carl is going to discuss our topology, which will lead into our implementation for the project.
Thank you, Corbin. So our topology is pretty simple, and we just needed a network that we could test our Ansible playbooks against. So it consists of, like I said before, a couple Cisco routers and Cisco switches, as well as 2 Juniper switches. On the ESXi server is hosting all of our VMs. So this includes pfSense, which was used to get internet access into this lab, as well as VPN. We have a couple sent to us virtual machines that have MySQL, Ansible, and Git running on them. So for implementation, we split the same network into 4 different sections. Dakota handled dynamic inventory and compliancy checking. Corbin handled configuration and archiving, and myself handled configuration deployments.
So I'm going to talk about the dynamic inventory collection portion first. So there's 3 basic tasks to be performed with that, and as you can see here, they are the network scan. So what we're going to do is we're going to use built-in tools with bash scripting in order to see what is all active on our network. We want to grab those IP addresses, and then we want to remote into those devices and try gathering any kind of information that we can. Finally, once the information is grabbed, we're going to store that onto our MySQL server as variables that can be used in later playbooks and scripting. The tools I used to accomplish that were Bash primarily. It housed the entirety of the script. And the 2 tools inside of Bash were both Nmap and a scripting language called Gawk. I also wrote a Python script to kind of help, if you're writing a future playbook and you want to reference, for example, those variables stored in the MySQL server, this will automatically grab those variables as defined. I want to, like, say you want to have all Cisco devices at stores X, Y, and Z. It'll grab all those variables from our MySQL server and put those directly into Ansible. So here's the general flow chart. You can see step 1 is that management network scan that I mentioned. That's going to use Nmap. Basically, it's put in the different subnetworks of what you want to manage or scan. I mean. Secondly, we're going to take that list of active IP addresses and see if we have any facts already stored on our MySQL server. This will help speed up the inventory or the fact collection process found in step 3, which is where we then take that active list of IP addresses and then rescan our network, seeing if we can find any kind of information about those devices. Finally, step 4, we take all of those relevant facts and store those back on the MySQL server.
Thank you, Dakota. So I was in charge of implementing the configuration archiving portion of the project, and it was broken down into 4 separate parts, each one using some different tools and technologies as displayed. First is the scheduled backups of devices, and then reports are going to be generated for any devices that fail to backup. And then I wanted to keep a revision history of all those backups. And finally, I needed to show changes between all of those revisions. So I'm actually only going to discuss 2 of the 4 parts, which I thought were the most important. So I want to begin with scheduling backups, as I believe that was the most important step. I used a single Ansible playbook to accomplish this for both Cisco and Juniper devices, as you can see on the right-hand side. In order to make this more automated and have the ability to be scheduled, I made the playbook run in a bash script. This way I could have a cron job, run the bash script, and it will automate the entire backup process for whatever schedule is needed. Secondly, now that backups are being generated, I needed to come up with a way to delete old files that were not needed anymore. I used a Python script to accomplish this part. There were 2 main criteria that needed to be met before a file could be deleted. The file needed to be at least a certain number of days old, and each device needed to have at least a certain number of revisions at all times. So as you can see in the image, I set a time period of 10 days before a file could be deleted. Then while there are more than 10 backup files for a device, and if those files are older than 10 days, it will be deleted till either none are older than 10 days or there's no more than 10 files left in a directory. This will loop through every device's backup files and make sure they are all compliant. I also have this script running from a cron job daily, making the process as automated as possible.
For the configuration deployment section, I picked 4 major repetitive tasks that network administrators usually face. Those are user management, SNMP, ACLs, and VLAN management. Ansible has built-in modules for both users and VLAN management. So it obfuscates the command away from you, and you just input the username or the VLAN ID that you'd like to configure. For SNMP and ACLs, they use the iOS config module, which can be shown on the next slide, please, Corbin. Thank you. With the lines command. So the lines of the picture on the right is an example of a Cisco playbook. You enter the lines that you would enter via CLI, and then for each task, but if you need to change context, you have to create a new task, which is shown in the bottom part of the right picture. Well, then you'd actually apply the ACL to that interface. For Juniper, it's even easier because they don't have separate contexts. You're able to type out the commands totally. So you're able to just type out the ACL commands that you would need to enter to configure the ACL.
So I was in charge of the configuration compliancy section. You may have actually seen in both Corbin's and Carl's particular sections that we've already kind of covered this. We wanted to integrate this with as many parts of our project as possible because it's just simple, good configuration management principles. But we decided to also make it an explicit section of our project. It comes with 5 basic steps. Basically, what we're going to do is connect to a remote device, and we're going to grab its current configuration file, then compare that to a locally stored intended configuration file. If there are any differences, we do want to note those differences, and we have an option or a decision to make here to either store those differences for administrative overview.
Unknown participant is now joining.
Or we can retain the ability to actually make those configuration changes automatically. So with that being said, we'd like to transition into our live demo. I will actually start right away with doing the dynamic inventory collection. So I'll be sharing my screen here, and hopefully this shows up fine for you guys. Let's see here. And is this big enough for you guys to see? Do I need to change any kind of text or anything like that?
I think it's big enough, Dakota.
Okay. So here I'm currently in our Ansible server. This is where we're hosting all of our playbooks and all the fun scripting that we've done. So just to kind of showcase my dynamic inventory collection stuff, the first thing I'll do is I'm going to show you our MySQL server, and please forgive my loud typing here. I'm going to execute this command, which will actually bring us right into our MySQL server. This is where we're going to store all of our facts. And you'll see through this command that we have an empty set. The server is completely empty right now. There are no facts currently gathered. So now I'm going to go back into our Ansible server, and I'm going to now run my playbook regarding the actual fact collection. And just showing what's in this directory right now. I mean, there's a couple different things, components of Ansible that are necessary to its function. But basically, you can see I have 2 playbooks here, and then these are Ansible-related documents, and finally a script called my for loop test that's going to show, or it's actually going to automate, starting this whole process. So to do that, I just type in this one simple command, and I put in our administrative password. This takes about a minute to run through our entire network. I actually have 2 subnets defined in here. So what you're going to see is a lot of these skipped messages, and then that kind of ugly red block of text. Now, that may seem like a cause for alarm, but actually that is put in there by design. So how a lot of our inventory collection works is we're going to try to, like say there's a new device on our network and we're trying to get into it. There are different methods to enter, different vendors, say between Cisco and Juniper. So what we're trying with this is we're going to try to enter these devices through the Cisco method, and if that fails, we're going to revert back to the Juniper method. And we kind of have this hierarchical, sort of like a waterfall method of going through each of the vendors ranked by like their popularity or the amount of vendors or those devices we have in our network. This allows us to actually access those devices automatically instead of trying to guess what they might be. So in a few seconds here, you'll see after we've discovered what kind of operating system they are running, we're going to access those, collect those variables, and then write them back to our MySQL server. So here, the script is actually done running. You can see here's the output. This is the generic Ansible output, this section here. I'll now go back to our MySQL server using that same command I used earlier. And then looking into the same table, you can now see we have all kinds of facts stored in here. I have things like host name, vendor type, store number, model of switch or router, OS version, all kinds of interesting things that can be referenced in future playbooks. So with that being said, I'm going to now hand this over to Carl, who's going to go through our configuration deployment section.
Thank you, Dakota. I will share my screen here. Is everyone able to see my my command prompt just fine?
Yes.
Okay. So for my section, I'm only going to show one playbook that I wrote. I wrote about 8 to 10 playbooks. I'll show one just for time. So the first one, the only one I'm going to be showing is configuring the ACL on Cisco devices. So I'll show that the ACL is currently not applied by pinging a device on our network. That ping is successful. Now I'll go back to the Ansible server. I'll show the files in this folder. So that includes the ACL playbook that I'll be running, as well as different ACL different playbooks I've created for this project. So I'll run the Ansible playbook command. I'm going to add the flag in here, ask vault password or pass. This is so that way we can encrypt the username and password for Ansible to SSH into the devices. So that way if someone were to look at the playbook, they would not be able to figure out the username and password. I will also add the /diff command, which will show the changes that the playbook made to the running config of the device. So execute that command. It'll ask me for the vault password. And the playbook will start. So first it has to configure the ACL in the configuration terminal context. So it shows that it's remoting into devices and changing those specific lines. Next, it will remote into the device again and configure and go into the context and configure actually applying the ACL to the interface. This red text up here is, I left this in here by design. So in the devices that we were running this playbook against, one of them was a router, and we were applying the ACL to interface VLAN 254. The router doesn't have that interface on it, but I wanted to show that Ansible, even if there was an error, it is able to continue applying the configurations that you pushed out if didn't fail forward. So the playbook is now completed. We can see here that it was successfully changed. The 2 tasks was successfully changed on 2 devices. The one that failed had 1 change on it, so it created the ACL in the configuration terminal mode, but it failed the second task. We can also see in here the line that it added for the 10.2 device. So I will go back to our switch that we ran the playbook against, run the same ping command, and we'll see here now that we are no longer able to ping this device. That concludes my portion of the live demo. I'll pass it along to Corbin to show his. Thank you.
Thank you, Carl. I'm going to share my screen quick. All right, so I'm currently logged into our Ansible server in our Git directory. We're hosting all of our playbooks. A couple key things to note, the 2 main playbooks I'm using are this backup config playbook, which is the one I described in the PowerPoint, where it'll backup configurations for Cisco and Juniper devices. And that is contained in this master script I have. For sake of time, I'm not going to show you all of that script. But that script will then run this second playbook if it detects any devices that were failed. So that's how I'm reporting any failed devices. This email.yaml file will generate an email to this Gmail account that I set up, and it'll attach the text file that is created from the output of running this playbook, and it'll see any failed devices, add them, and email them out. So reports are instantly generated, and you can instantly know of any devices that failed. So all I have to do to run this playbook is this 1 line of the script. So first, what it's going to do is clean up that old host file, and it's going to query Dakota's database using some formatting for all of the IP addresses. It'll assign some additional variables. It'll build that host file, run my first playbook. While it's doing that, it's going to run through Cisco devices first and skip any Juniper devices. And then after the Cisco devices are done, it'll then go back and run through the host file again and pick up any Juniper devices and run its backup configuration commands against it. So we can see that if there was a failed device, it's going to email those devices to Menards Capstone at gmail.com. This could be set up for a locally hosted email server as well, easily. This is the output from that second playbook running. It's actually gathering some facts from this server, getting the timestamp, because in the email it will attach the current date it was run on with the time of day. So it's sending that mail. We can see it's successfully completed. A failed devices report was generated in this log location, so we can actually go in there real quick. There's actually been a lot of failed devices because I have this running in a cron job. You'll see a lot of 12 a.m. and 12 p.m. It's running once at noon and once at midnight. I'm actually going to show you that email reports are being generated. So I'm going to switch to my other screen quickly. So here I'm logged into that Menards Capstone email account. I'm going to refresh this quickly. So we can see that a new email was sent at 11 a.m. We can open this up, but the subject will contain the current date plus the time of day. Attached is a list of devices that we failed to archive. We can open this, and you can see that this IP address failed. And how this is accomplished is by grepping the output of the playbook. So any failed devices will show up in this text file. So that wraps up my portion, and I would like to now hand it back off to Carl, and we're going to kind of break down how much time we spent on this project.
Thank you, Corbin. So this is our time spent graph on the project. It's pretty fluctuating. In week 5, there was a dip. That was kind of where we were approaching spring break, and everyone was thinking about taking a break. After that, the school shut down, and we were able to get a lot of work done during those 2 weeks following the school being shut down. During those 2 weeks, we were able to complete the majority of the project. So towards the end, we were able to have to do less work week by week, just writing documentation and polishing it up. Totally, we spent 408 hours on the project. Some non-technical challenges that we faced. The first one being communication. We used email as our main form of communication this semester. I think if we were all to go back and start this project over, we would continue to use email. It is a very valuable tool, but also supplementing it with a more casual way to converse via Discord, Teams, Facebook Messenger, or something, so we were able to get faster responses from the group members if needed.
We also learned a lot about project management throughout this semester. We at the beginning, we kind of struggled to focus on a lot of the administrative tasks that were assigned and deciding on kind of who would do them and when they would be done. Fortunately, throughout the semester, we came up with a system that worked by dividing it up week by week and assigning that to a person, and we were able to push through and be successful.
And finally, one of our last non-technical challenges was, with this project being a research project in its nature, we found a lot of, we had a lot of ways to kind of complete these different challenges in the project. This involved us, looking into a lot of different technologies. That's how we kind of came up with, the MySQL server. We came up with, using Git, Python scripting. There's lots of different little things that were looked into that we had to be considered, and then once we determined yes or no if we should use this particular tool, that's when we were able to start moving forward with the project.
And we did have a few technical challenges and lessons learned from as the group as a whole. Ansible, the first one being Ansible, was kind of a completely new technology to us, and it took us quite some time to learn it. We had to work together and kind of teach each other how to use it and some of those best practices. So we would individually be rerunning our own playbooks, and then we kind of conglomerate and collaborate together to figure out what was the best way to do it. And we learned a lot, and we learned to also persevere and keep pushing through that. And I'm very proud of the work we did.
Another big technical challenge that we had was our group as a whole. We weren't incredibly familiar with a lot of scripting practices and programming practices. So jumping into Ansible and database administration type stuff with MySQL and trying to learn this whole new YAML format through Ansible, it was a long learning process, but we spent a lot of time sitting down with each other. I'd learn something, I would share it with Carl and Corbin. They'd find something out, they sit down and share it with the other two. It was a lot of back and forth, building each other up, sharing this this exchange of knowledge, and a lot of cooperation throughout the project is what made it really work for us.
One of the last technical challenges we faced was the new to Juniper switching. Stout teaches us Cisco switching. They also teach us the fundamentals of networking, which is very beneficial. But there was a learning curve to get the Juniper switches up and running on our network, trying to transform the Cisco commands that we're used to into Juniper commands. Also having to create Cisco playbooks, which once we understand Ansible, went very smoothly, but then having to adapt those Cisco playbooks to the Juniper system was a bit of a learning curve. Eventually we figured it out, and I'm glad that I had the experience to work with Juniper switches so I could expand my networking.
And finally, our final recommendation regarding Ansible. We do believe it is a great automation tool when it's configured correctly. It's a very powerful tool. It can really cut down on those administrative times. A lot of menial tasks can be quickly automated, and time can be freed up for your engineers and administrators. However, we did find that Ansible doesn't readily replace everything. It did have to be supplemented with several other tools, as you guys saw in our presentation, to really be effective at larger scale. One of the major things I'd like to point out is, for example, Ansible's inventory file system. It uses both the YAML and INI formats. It's optional which one you use. But the way they're structured is hierarchical. So trying to make that kind of hierarchy between devices doesn't really work when you're trying to scale it out well with lots of individualized facts for each individual device. So that's where we had brought in things like MySQL server and also like GitHub to manage all these different changes.
With that, we'd like to wrap up this presentation today by saying thank you to our sponsor Menards for giving us such an interesting project to research and implement. They also supplied us with 2 Juniper switches, 1 Cisco switch, as well as 2 Cisco routers. So it was awesome to get at least a little bit of experience and exposure to Juniper. Is like Carl said, mostly here at Stout we deal with Cisco equipment. I also want to give a big shout out to the CNIT program and all of its staff, as our group's been in the program 4 years and we've learned so much from them, and it's been an amazing learning experience. Also want to thank UW-Stout and more specifically our program director, Holly, for putting together this Capstone class and also organizing sponsors for different groups. She's always been there for students if they needed anything, and she was also behind the scenes in this class, making us all look good. Finally, I want to thank everyone watching here today. It really does mean a lot to us and the rest of the class that we get to present this our work throughout the semester in front of you, and I really hope that Menards and everyone here can take away some points on configuration management, why it's needed in companies, and how it works in a test environment. With that, we'd like to open the floor for any questions anybody might have regarding the group or any parts of the project.
Yeah, this is Justin from Menards. I did a quick question. When you're showing how you're deploying configuration changes to multiple devices, you showed how it failed on like a router, or if it was a destined to be a Cisco switches only and it hit a Juniper. Can you put logic into your scripts so that it uses that inventory you've taken to minimize the error counts? So if you're deploying to thousands of switches, you could have hundreds or thousands of errors if you were just using the mass list.
Yep.
I think I can answer that one.
Okay, go ahead, Dakota.
So yeah, that's actually what the MySQL server was set up for. We left in those errors in our other sections of the projects to show that Ansible can actually keep going forward if it does detect some kind of error, whereas in other scripting languages, you're going to stumble on those and probably break your script. So the logic we actually built for that was I mentioned my Python script that I wrote. This is actually something that you can put in just like a spreadsheet of, I have all the variables in our SQL server on there. Make a list of, I want, stores X, Y, Z. I want all the Cisco switches out there that meet, this OS version, for example. It'll automatically generate a MySQL query and then build an inventory list for you automatically. So that's the kind of logic that we built in order to fix that that kind of issue that you mentioned.
Okay. And I just had one other question. So is there any best practices when using a tool like Ansible for mass deployments? Does it do multi-threading when it's deploying changes, or is it kind of like in a more of a serial fashion? Because if you're deployed to, like, say 5,000 or 10,000 devices, it could take a long time for that system to log in individually and go one at a time.
I suppose I can answer that one too. So Ansible was actually originally written for server administration tasks, and as I mentioned earlier, Ansible is agentless. However, on the back end of Ansible, it actually runs Python. So how that works is it's going to execute these Python scripts on each of the end devices, so that kind of distributes that processing power. However, with network administration tasks, it's a whole different ballgame, because a lot of routers and switches, I think Juniper might support it, but for the most part, Cisco does not. Installing Python on those end devices be able to kind of distribute that processing power. So ultimately, when you run these sort of playbooks on the Ansible server, it's going to execute them all locally. So really what it comes down to is you have to scale your hardware in order for a network administrative task to scale well with larger inventories.
I just want to add something to that too. Like you said, we were asking like serial or multi-threading. Ansible does how it executes its playbook is play by play, so it will finish an entire play before it will move on to the next play. You can't have those running like unless you put that play in a different playbook and run it in a separate terminal. It will go sequentially top down through the playbook until it's finished.
Okay. Well, on behalf of Menards and the team over here, I'd like to thank you guys. You guys did a really good job. And it was a pleasure, obviously, having you guys a couple of you guys as interns, but also to work with the whole team as part of this project. And I know you guys learned a lot, but so did we, as we worked with you, and we look forward to hopefully implementing some of your guys' ideas. So thank you and good job.
Thank you, Justin.
Thank you, Justin.
Thank you.